Today we're going to talk about evaluating expressions. So we did order of operations with numerical expressions. Now we're going to apply that to an algebraic expression that has a variable. So just a couple of reminders. So a variable is a letter used to represent an unknown value. And an algebraic expression is something that contains at least one variable and one operation. So the only difference between this and order of operations is that there's variables in it. Remember that when we say to evaluate, that just means find the value, find the answer. Substitute. If you think about a substitute teacher, they are there in place of another teacher if the teacher is out, right? So if we're asking you to substitute, that means to put in place of something. So, in algebra, substitution means to put numbers where the variables are. So basically, we are substituting a number for a variable, or replacing it. So the steps to evaluating expressions, we are first rewriting the problem by replacing the variables with the given values. Then we're going to use the order of operations, PEMDAS, to evaluate the problem. So let's look at this first set, problems number 1 through 3. We are going to evaluate if x equals 6 and y equals 5. So for this first one, we've got 20 plus y. So what I'm going to do is I'm going to substitute the value of 5 in for y. So the first thing is I'm just rewriting the expression. Now I'm going to actually evaluate, find the answer. 20 plus 5 is 25. So our answer is 25. Number 2, 3x minus 2y. So the first thing I want to say about this one, 3x, the most common mistake that I will see for this is people will write 36 minus 25 because they are saying, oh, well, I'm putting the 6 in for the x, I'm putting the 5 in for the y. This is incorrect. Do not do that. When we think back to the different ways to show multiplication, when you have a number written right next to a variable, that actually means that you are multiplying. So when I'm plugging the value in, I'm going to use parentheses to show multiplication. It's 3 times whatever x is, and in this case x is 6, minus 2 times whatever y is, and y is 5. So when we're doing order of operations, we made you do a separate step for each one. In this case, we're okay with you showing the multiplication of both of those at the same time. Remember that we multiply before we subtract. So 3 times 6 is 18, minus 2 times 5 is 10. And then all we need to do is our next step, which is to subtract 18 minus 10, and that gives us 8. Then we have xy plus y squared. So just like before, we're not writing xy as 65. We're not saying x is 6, y is 5, so it's 65. When you have two numbers written right next to each other, even if it's variables, that means multiplication. So again, I'm going to use parentheses to show multiplication. X is 6 times, using parentheses, y, which is 5, plus y squared, so 5 to the second power. So over this next step, I am going to show that I'm going to do the multiplication here and the exponents. It's okay if you do them at the same time. If you want to do them separately, that's fine too. So 6 times 5 is 30, plus 5 to the second power is not 5 times 2 equals 10. That's wrong. Remember, 5 to the second power is 5 times 5. 5 times 5 is 25. And then our last step, 30 plus 25 gives you 55. All right, the next step, and then we're going to have you try the rest on your own. So for 4 through 6, we're going to evaluate if A equals 6, B equals 4, and C equals 10. So for number 4, I'm going to plug in C is 10 minus, and then in parentheses, A, which is 6, plus B, which is 4. So per the order of operations, the first step that I have to do is parentheses before I subtract. So within the parentheses, 6 plus 4 is 10, and then I'm carrying everything else down. 10 minus 10. Well, all we have now is subtraction, so 10 minus 10 is 0. That is our answer. All right, number 5. We have AC with a fraction bar over B. That can be kind of confusing, but remember that a fraction bar actually means division. So I'm going to rewrite this expression with that fraction bar, but plug in the numbers. So on the top, we have A next to C, which means A times C. So I'm going to show that with 6, which is A, times our C value of 10. And then our denominator on the bottom is 4. Okay. For the fraction, I'm first going to simplify that number on the top. So I'm going to simplify. 6 times 10 is 60, and I'm still writing it over 4. So for the final step, what we need to remember is, again, the fraction bar means division. So we're doing 60 divided by 4, which is 15. All right, one more, and then we'll send you off on your own. A squared plus B squared plus C to the third power. So I'm going to first rewrite all of this. This is 6 squared plus 4 squared plus 10 to the third power. So again, rather than doing one step each time, I am going to just rewrite all of these on this next line. So 6 to the second power is not 6 times 2. It's 6 times 6, which is 36. 4 to the second power is not 4 times 2, it's 4 times 4, which is 16. And 10 to the third power is not 10 times 3, it's 10 times 10 times 10, which you can plug into your calculator, or the trick is if it's to the third power, there should be 3 zeros. So the final step, I'm just going to add those together, and you should get 1,052. All right, on the back, I want you to evaluate for the first 2 problems, or for the first 4 actually, if A is 6, B is 8, and C is 2. Go ahead and try those and then get your answers checked.